IoT trend has been around for the last decade, and now its products are more accessible and efficient than ever. In today's video, I'll share how I'm using Raspberry Pi, a tiny device that can be your almost zero-cost backend running at 24/7, so you think whether you could use it too. Until recently, I used cloud services for my personal projects and professional POCs, primarily on Microsoft Azure, because Azure has historically been the best fit for .NET. For most of my POC workflows, or whenever I needed to run .NET service, I would typically spin up app service or a small VM, which was convenient but came with monthly cost of around $50, the money I wanted to save. That led me to explore how I could run my simple workflows without relying on full-fledged cloud VMs. I didn't want to have a dedicated desktop PC running at 24/7, as power consumption and size are pretty noticeable, and I don't have a spare server room to keep things. And that brought me to the topic of IoT, which has been around for years, and finally I started thinking on how I could personally use it for myself. So in this video I'm going to explain it using my personal Raspberry Pi device as example. Just before we dive in, let's define what Raspberry Pi actually is. A Raspberry Pi is a kind of mini computers, or so-called single board computers, where you have everything like CPU, memory and all interfaces integrated on one tiny board. Due to its small size, you can literally carry it in your pocket and you can place it anywhere in any place. But at the same time, it has ARM-based processors that can run a full operating system like some Linux distributions or even Windows versions for ARM. And it could be fully autonomous due to its small power consumption. There are a few generations of Raspberry Pi currently available on the market. Typically, the higher the generation, the higher the specs and just a little bit higher the power consumption. My device specifically has quad-core ARM-based processor, Cortex R76, if I'm not mistaken, 2.4 GHz. It has 8 GB of LPDDR4X memory. To my knowledge, currently the most recent version already have up to 16 GB, but even 8 GB is perfectly fine for my tasks. A virtual machine in the cloud with similar specification would cost you around $80 per month, which is almost the full price of this device. And there are of course some alternatives to this device on the market from different other vendors, which could perfectly fit for the same type of task that I'm describing in this video. I've chosen Raspberry Pi 5 just because it was the most recent Raspberry on the moment when I bought it, and because it's quite popular and widely available. It has many tutorials, videos and instructions on the internet, so you can find literally anything about this device if you want to do any kind of workflow with it. The Raspberry Pi is a pocket-sized powerhouse packed with possibilities. You can transform it into a retro gaming console to relive classic titles, or build a smart home hub to control lights and temperature. Create a tiny web server to host your own blog, or even attach sensors for a weather station that updates you in real time. Back to my use case. I have an Ubuntu installed on it when I host my pet projects, which I use in my daily work. For example, I run a custom service that uses Mermaid.js to generate charts for Jira dependencies on my work projects. Later in this video, I'll show you step by step how I set it up. The bottom line is, Raspberry Pi or similar single board devices could be used just about anything, and the only limit is your own imagination. Now I'll show you how I use mine. We start with main components. Here is Raspberry Pi 5 board itself, which has everything needed built in: CPU, memory, interfaces. It has USB ports, Bluetooth, Wi-Fi on board, and micro HDMI to connect external monitor. In addition to the board, you'll need a power cable and some form of storage, typically an SD card. I also have a case with built-in fan, recommended for continuous operations to keep things cool, and a micro HDMI cable in case I need to troubleshoot locally if SSH ever fails. The fastest way to install OS is to go to the official Raspberry Pi website, where you can find and click on the Software tab. Here you can choose to download Raspberry Pi OS Imager app for your current operating system. In my case, I download macOS version, and then you just need to run installer and install it. Then just run the Imager application and you'll see a very simple interface with few options. The device for which you do the installation, which is Raspberry Pi 5 in my case, and operating system. I use Ubuntu Linux. Just use the latest stable version of Ubuntu which you have. After you choose operating system, you might want to bring up the advanced settings by clicking Command-Shift-X on macOS or Ctrl-Shift-X on Windows. This window allows you to set up some pre-configuration for your device. So there you could configure your hostname, user and password, Wi-Fi settings for automatic connection, and more importantly, pre-install SSH configuration, so that after installation and run you could just connect to your device remotely via SSH without connecting keyboard, mouse and monitor. Then you just need to choose your storage, which is SD card in my case, where the operating system will be set up. Installation can take a while, so you may consider doing a coffee break. After installation is finished, all you need to do is to connect your storage, for example an SD card, to the Raspberry Pi and power it up. It takes less than a minute for it to load the Ubuntu. So the next step is to connect to our Raspberry Pi device remotely via SSH and check that everything works correctly. So here we go, we now have Ubuntu 24.1 installed on our Raspberry Pi device, and we connected to it via SSH. Now, before we proceed to anything, I update the package's version info with sudo apt update command. Also, if you didn't pre-install SSH, you might want to install the OpenSSH server with sudo apt install OpenSSH server command, and then ensure it's up and running. Now back to my personal case, I need to install a .NET runtime to run .NET applications on Ubuntu. You can refer to the official Microsoft documentation and just copy commands to your CLI to install SDK or just runtime to your Ubuntu. Right after that, I just create a service file for the application and configure it properly. I set description, working directory, exec start command, and a user from which I run it. This file should be in the etc systemd system folder, where all services reside. To make your application working, you need to register it as a service. You do it with executing 3 commands: systemctl enable, systemctl start, and systemctl status. As you can see, my service now is up and running on the 5005 port, which I configured as a part of application configuration. Now, to test it, I just go to the web browser and call the endpoint, which returns my Jira dependencies rendered with Mermaid.js framework. Also, Raspberry Pi 5 is small enough to place anywhere. I keep mine in the hallway right next to my Wi-Fi router. It's powered by pass-through power bank, which charges itself while simultaneously supplying power to the PI, allowing it to run 24/7. Speaking of 24/7, let's see how much you'll pay for such configuration. As per Raspberry Pi 5 specification, it should consume 3.2 watts in idle mode, meaning without any workload. For normal loads, it consumes something between 5 and 7 watts, and in stress conditions, consumption may go up till 9.8 watts. My device isn't spinning in any peak modes definitely, so let me calculate approximate cost for normal consumption of 5 watts. For daily usage, it will translate to 0.12 kWh a day, which is 3.6 kWh monthly and 43.8 kWh yearly. Electricity costs vary widely based on region, but let's assume a ballpark rate of $0.12 per 1 kWh. Based on average power consumption of around 5 watts for normal workloads, it translates to roughly 43 cents per month and $5.3 a year. For this money, you get essentially an always-on backend for your small or medium workload. That's it for this video. I tried to explain you how I set up and use my Raspberry Pi device. I used only one example with one application, but essentially I run many services on it. If you enjoyed this video, please hit the like button. If you own a Raspberry Pi or a similar single board device, please let me know in the comments how you are putting it to work. You've been watching IT Launch channel. Have a great day and see you soon. Cheers.